Okay, this is our example problem for section 9.2. Our quadratic function, our quadratic equation is y equals negative 3x squared plus 12x plus 1. Notice the first thing I do is I mark my a, b, and c values. Just write a little a, b, and c underneath there. This is helpful when you plug in your b and your c or your a value for your quadratic formula once we get there. But for right now, for your vertex, for your axis of symmetry. So just go ahead and mark those there. Be sure that you notice the signs. For example, in this problem, our a is negative. That tells us a few things. It tells us it's going to face or open up downward. It tells us about how narrow or wide it will be. But at this point, we just want to mark those so that we can do our first step, which is find our vertex. So finding our vertex, we start with our axis of symmetry, where x equals opposite of b over 2a. So we plug in our opposite of b, 12 here, over 2 times a, which is negative 3. That gives us negative 12 over negative 6, which gives us a positive 2 for our axis of symmetry, which again is also our x value for our vertex. If we have the x value for our vertex, we find the y value of our vertex by plugging in that x into our quadratic equation and calculating our y. So we plug in 2 for x, and we get that our y is 13. Okay? So our vertex for this quadratic equation is 2, 13. Our second step is to find that y-intercept. We need our second solution point. In order to graph this parabola, we need our second solution point. We are going to find our y-intercept for this one, which is when x equals 0. We should realize that when x equals 0, from our linear equations in chapters 4 and 5, we know that when we plug in x equals 0, y equals whatever our constant is. So for our quadratic equation, when x equals 0, y is going to equal c. For this specific one, y equals 1. So our y-intercept, our second solution point, is 0, 1. So what I've done now is I've graphed these. I'll walk over here, try to keep it a little steady. All right, so we've graphed those first 2 points. All right, take a look here. We've got our vertex at 213. See that up there? Then we have our y-intercept at 0, 1. See that guy there? All right, next step, our third and final step. We're going to find our third value that we need, and we find that by reflecting the y-intercept, that second value we just found. We're going to reflect that value across the axis of symmetry. So our intercept was 0, 1. There it is. The axis of symmetry was at x equals 2. We already found that in step 1. We're going to take the same y value for our third point as our intercept. If you think about the y-axis, or excuse me, if you think about the axis of symmetry as that fold where the parabola is going to reflect upon itself, then that 0, 1 intercept is going to reflect across the axis of symmetry, and it's going to land, it's still going to be at positive 1 for y, but instead of 0 for x, it's going to go 2 over to the axis of symmetry, and then another 2 over for where it lands on the reflection. Okay? So our final point that we need to graph our parabola for this particular function is going to be 4, 1. Okay? So again, in our example, we label A, B, and C. We find our vertex by first finding our axis of symmetry. That's our x value of our vertex. Plug it in and get our y. Then we found our second point. the y-intercept in this case when x is 0 and y equals c. So those are two easy points to find. Then the third point, we don't have to calculate it. We just reflect that second point that we found, that y-intercept. We reflect that value across the axis of symmetry. It's going to have the same y value. The x value is just going to change by the distance from the axis of symmetry. All right. Good luck with your homework. 7 to 27 all.